Hello, everyone. Thank you so much for staying for this 5 o'clock on Wednesday afternoon. My name is Rebekah Rounds. I am moderating the panel on big data and constellation satellites. I'm here with three experts in the field of big data. We have Melanie, Corcoran-Freelander, Ohad Harlev, and Christopher Richins. To give you a little bit of information about each of our panelists today, Melanie Corcoran-Freelander is a 20-year industry veteran. She ran and developed multiple US government R&D big data and remote sensing technology programs for over 10 years. Melanie is CEO of Analytic Fusion and a former CTO of Ursa Space. She is, in those positions, she created technology roadmaps and provided strategic corporate development for commercial and government entities. She fuses her network and capabilities in both business and science with top university professors, national labs, and commercial industry to bring innovative new space capabilities to the US. Ohad Harlev. Ohad is currently with LyteLoop, and prior to co-founding LyteLoop 3 to 5 years ago, Ohad had spent most of his career leading various satellite service providers. His last role with the president of RSat America, presently known as MX1, which was acquired by SES. And finally, we have Christopher Richins. Christopher is founder and CEO of RBC Signals, a provider of global satellite communication infrastructure as a service. Christopher began his career as an RF communications engineer at Boeing Sea Launch, where he supported multiple launch campaigns from the ship-based Equatorial Launch Site. After business school, Christopher completed an internship with SpaceX before joining Bain & Company as a management consultant. Post-Bain, Christopher has held management roles at Arcade Astronautics, Planetary Resources, Space Angels Network, Expedia, and Applause. Richens earned an MBA from the Darden Graduate School of Business at the University of Southern California and a bachelor's degree in electrical engineering from Brigham Young University. He lives in the area with his family, in the Seattle, Washington area with his family. So what are we here to talk about today? We're here to talk about big data. Big data. What is big data and why is it so important? How do we gather it? How do we transport it? And what is the role of a constellation satellite system in our current and future use of big data? How do we synthesize it? Should we keep it forever? And finally, what does the future look like with our use of big data? So with that, we're going to start out with Chris Richins. And Chris is going to talk to us today about the gathering and transportation movement of data from space to here.
Awesome.
Chris?
Let me grab the clicker here. While we're working on bringing up the RBC signal slides, I can tell you a little bit more about what I'm going to talk about. So because I'm first, I got nominated to talk a little bit about what is big data, and this is something that has been a topic for a number of years. In fact, as I was going back, as I was going back and doing a little bit of research, one of my friends, Amaresh, led a panel very similar to this, and it was a hot topic, and it was back in 2014. So this is something that is not necessarily new, and in fact, it's been part of my presentations that data is the new oil and things like that, and it's all very relevant to space because space is a very unique vantage point from which to gather immense amounts of data very quickly. And so when it comes to big data, usually big data is characterized by the 3 V's. So they're talking about volume, data variety, and data velocity. And in fact, this is the splash page from Amaresh's presentation back from 2014. So really quickly, I'll tie this into how does this apply to space. So in terms of data volumes, as you start to move more data, as the pipes get bigger, there's always more data there to fill it. And many of you might be familiar with some of the different frequency bands that satellites use to communicate data back to the Earth, because right now everything has to be done wirelessly. There's not an extension cord long enough to run it out to orbit. So they're basically sending it back via radio frequency. And the first 4 of those are all radio frequency bands. And then the last one is an optical band, which those are all on the electromagnetic spectrum. As you go higher in frequency, theoretically, the data rates that you can transmit at those frequencies increase. And so what we see are spacecraft are kind of graduating up this schedule where CubeSats and small satellites are generally at the lower end of the V and UHF, and we see satellites in the S and X band commonly today. We see the very beginnings of Ka band starting to come into commercial utilization, and we're starting to hear talk about optical being what's next. And so we see, much like in data trends around the world, that data consumption and data transfer rates are increasing in space as well as in terrestrial applications. So when we talk about data variety, we're talking about, if data volume is talking about maybe in a spreadsheet how many rows you have, data variety is how many columns you have, how many different measurements are you taking. And so space enables a lot of different measurements. So I've listed here a few. There are many, many more. And basically what we have here is that as you take these different measurements, for optical, for example, you have resolution across 3 dimensions that can be varied. So you can have spectral resolution. So what, are you looking at infrared? Are you looking at optical? Are you looking at something different? Spatial resolution, how big is a pixel in your picture? Can you read a newspaper from space, or can you only see something very broad? And then temporal resolution, how often are you flying over a location to be able to gather data from that spot on the Earth? And each of the different Earth observation constellations that are out there occupy a different spot on in this 3-dimensional space of resolution. And so the data that is generated by those can have great variety, and so it makes for a very rich data set. And then finally, we'll talk about data velocity. And so it's how fast is data being fed into these systems. And when we look at the forecast growth of spacecraft, the data volumes that are associated with those, because you have a compounding effect when we talk about data volume, because not only are we having more sources of data in terms of the number of spacecraft that are being launched, but the data generation capability of those spacecraft is also going up exponentially as that's happening. And so the overall data volumes that are being generated are impressive, and we'll talk more about that as we get into the presentation. But generally speaking, anytime that you have the combination of volume, variety, and velocity, those tend to be the gnarly problems that people call big data. And it's there that a simple spreadsheet generally won't do to be able to actually derive value from those data sets. So it's been a problem not just today, but for many years, that we generally have more data than we know what to do with effectively. And what we're going to be talking about on the rest of this panel is how do we use that data and use machine learning and other techniques to be able to extract value from this overwhelming, or what would be overwhelming, source of data if we didn't have these new and interesting techniques to be able to analyze it. So I will talk very briefly about some of the challenge in getting all of this data back from space to the ground, because that's one of the problems that my company at RBC Signals that we solve. Because right now today, if you've got a satellite up in space, the antenna or the ground station, the satellite dish that's going to communicate with that, has to point at that satellite as it's flying by. And that dish can only talk to one satellite at a time. And so if we're starting to talk about thousands of and tens of thousands of satellites being in space, and you can only have one dish talking to one satellite at a time, you can see how that problem doesn't scale very effectively. And back when we just had a few dozen satellites, it wasn't a problem. Now that we're into bigger and bigger numbers, we need better technology. But then once the data gets on the ground, you've got this backhaul pipe, which becomes another problem. When you were just talking about a few megabytes of data a day, moving that volume of data around the planet isn't a problem. As we move into petabytes of data, then backhaul cost starts to become a driving cost in the overall mission cost of a spacecraft. Then once you've got that data somewhere, how are you going to store it? How are you going to process it using all these techniques that we're going to be talking about? How is that data then sold and then delivered finally to the people that are going to generate value from that? And this whole pipeline ends up being bottlenecked in a few key areas. And one of the things that our company RBC Signals is doing is really trying to open up some of those bottlenecks. A few things that we're doing are we are making it so that a ground station can talk to more than one type of satellite. So we call that a multi-mission architecture, where we have software-defined infrastructure that can be configured rapidly in between communication sessions so that they can communicate with, a single ground station can communicate with multiple types of spacecraft. We're also looking and working with partners that are developing technologies that will allow multiple spacecraft to be able to communicate with a single antenna on the ground at once, what they call multi-beam antenna technology. And then integrating that, that ground station with the data center so that the storage and compute doesn't actually have to happen in a centralized location, but that can be distributed out to what we call the intelligent edge. And then by licensing that data that's coming through the network, be able to process it in place and distribute it with very low latency from those globally distributed ground stations. And so we're excited about the fact that we've got this global network. We've got over 50 locations, or around 50 locations now, around the world where we can facilitate this type of communication. And so now that we've broadly laid out the scope or the volume of the data and how we're going to get it down, I really am excited about turning it over to the people that are going to talk about how to make money from it.
Great, thank you so much, Chris. Now we're going to have Melanie talk about what we do when we get big data, and
I'm going to stand if that's okay.
Oh, absolutely.
All right. So I have 15 minutes to explain how a bunch of the players in space are doing data analytics and fusion. So I'm actually not going to do a great job, but I'm going to give you a brief overview of it, and then you can ask questions later so that we can also get to the other briefings as well. So some of the questions that I was asked when we were doing our prep for the panel is why now, who's benefiting, and who are some of the players in the constellation, and what are the applications they're bringing to the market. If I could paraphrase one of Megan, who was the previous panel moderator on there, she wrote, "Space is cool, but revenue is hot." So what is the data analytics? And also, thankfully, I had all these precursor people today. So thank you to all the other previous panels, specifically the one on the perspective on space investment. Sunil asked, what were these inflection points? And then some of the other questions were, sorry about that, what is causing these models to work and why will these models work? So commercial space used to be in the realm of governments. So why now? Why this inflection point? Because now, with the growth of small sats and the growth of launch from the previous panel, this area is now open to the commercial sector, and it was previously only the government domains. So that's one of the biggest factors. The other one has been the proliferation of cloud resources. So now there's actually the compute to process all this data. Launch, obviously the cost of launch has now gone down. And then there's this beautiful potential that every single person in this Space 2.0, they go to the venture community because there are these untapped revenues, right? And if they weren't there and we tapped them already, then I wouldn't be up here. So what are the benefits that small sat data brings you? And it's the ability to see what we could only dream of before. So previously, maybe government had their national technical means, but you either had to trust someone in a, I always say this wrong because I'm dyslexic, OECD country, that they were telling you the right information, or you had to have some other insider capability. Well now, with all these different satellites that are up there, I can be monitoring all the shipping traffic, I can be monitoring ports, I can be watching things in things like Planet Labs. With SAR data, I can do day, night, all weather. People in the analytics companies now have the ability to find, monitor, and predict. And obviously with that comes tracking. So what are some of the sectors that benefit? And if I'm going really quickly, I'm sorry, again, 15 minutes. So environmentally, this has been one of the areas, I'm working with Nat Geo right now on digitizing parts of Sentinel, so ESA space 10-meter data, so that we can literally do land cover classifications over the world with free data so that we can get a feel for how has the world changed since ESA's been imaging the globe. Then supply chain improvements. So if you've ever had the chance to hear Peter briefing on Spire, it's fabulous, but his goal is to increase GDP by 2%. So by knowing all the factors that go into your supply chain, you can reroute, you can prepare. If you were like a FedEx or Amazon, they use this type of technology with other open source data and the data they collect on you when you're ordering things to figure out where to pre-position warehouses. And that's all about the supply chain logistics. So this space-based data is really critical in terms of both understanding what's going around the globe and what's happening locally. Some of the other ones, be predictive, more accurate weather. So I believe Ms. Rich talked about Planet IQ. And there's also Spire has its own weather occultation. I think about a 5-day forecast is 80% predictive. And so now you have the ability to start planning where your resources should be. If there's going to be rain, okay, maybe I don't want to go out and pick on a harvest time. Or for those who are using some of the Descartes products, you can know and have predictive yield something like 180 days before USDA reports on it. So for traders, you're talking massive arbitrage capabilities, and this is not considered insider trading. Because this is, in many ways, you can buy this data. It's out there. It's not public, but it's not insider trading. It is data that you derived and you provided the analytics on, and it's giving you decision advantage. So one of my favorite things is if a picture is worth 1,000 words, what is an answer worth? Especially an answer that you know before everyone else. So some of the companies, I've touched on them, but you've got Spire with their AIS, ATSB, that's aircraft, weather occultation. Today we had spaceflight also talk. You've got BlackSky, Planet, Digital Globe. Those are all doing EO. You have Hawkeye doing RF, and then you have the Capellas, the Umbras, the iSize doing SAR, OneWeb with their Wi-Fi. And then these are the analytic providers. So as I was saying previously, Sunil had said, all the hardware people right now represent something like $16 billion worth of infrastructure investment. And there's less than $1 billion in the analytics companies. Now, granted, some of the Spires and the BlackSkys are playing in both sides. They're both selling their data to other analytic fusion providers, not my company, but people who are fusing other analytics. And they are also creating their own analytics, right, to do tracking. And you'll see some of their products a little later. So certainly, they recognize that the future of Space 3.0 is generating those revenues that matter to the end customer. The end customer doesn't care that it came from space. They just want to know that they can trust the answer, that they can get it before everyone else, and that it's accurate. So I have a couple of examples from different companies here. So Ursa Space, in many ways, they're trying to be an Uber for SAR. So they don't own their constellation, but they have over 19 satellites in their virtual constellation that they can task, and then they do the analysis, and then they provide that analysis with contextual information to their oil customers. So this is actually a really cool image because this is SAR, which is normally very ugly, and it's the domain of machines. But they have turned it into 3D data, and they literally measure the floating top tanks around the globe every single week. And they have an idea of the oil inventory component around the globe for the energy equation. So they're measuring something like 3.6 barrels every week over 10,000 tanks, and with a 96% absolute correlation to the other key metrics. And their numbers come out before EIA's numbers come out. So you're seeing, if you're a trader or you want to have decision advantage, the new remote sensing world, the analytic world, these new small sat constellations are really providing you that decision advantage once you know how to get the data, clean the data, fuse the data, analyze the data. And with the advent of the machine learning and the deep learning, marketing-wise, I guess they're calling it AI, you're really able to take advantage in cloud environments of processing petabytes upon petabytes of data. So BlackSky has their global intelligence platform. So they're monitoring a number of key IoT data, a lot of open source data with natural language processing, and they're correlating those events to using their satellites to monitor key facilities for various different customers. This was something that only governments could do before, and now you're seeing a private company come out there and create these custom products for people that need to get a sense of what's happening at my facility. Is it safe, or can I travel there? So if your facility is a high-risk facility, now you don't need to go there anymore. You can pay someone like BlackSky to monitor your facility, or monitor your competitor's facility to understand what they're doing. So it's a great source of business intelligence and competitive advantage. Oh, I'm sorry, I didn't do them justice. Change detection, indications and warning, high revisit, and these predictive analytics. So when you fuse this open source data, the natural language processing, and then the image interpretation with a high revisit rate on key target facilities, you really start to get something that we in the old defense industry called pattern of life. And then once you know what a pattern of life is, you know what an anomaly is. So you know what something's unusual. And that's when you care. So the big problem for the satellite providers is most people don't care about the bulk of their data. They just care about the pattern and the anomaly. And that's where some of the business models still have a little bit of a ways to go to evolve. What are companies like Descartes Lab doing? So on the AI front, a lot of people have mentioned that AI is, if you're not in AI, you're not going to be here in 3 years. So Descartes basically was a spin out from the DOE, Los Alamos National Lab. They took that whole team so that Facebook and Google couldn't just pull them out of the labs. And they created what is like a data refinery. So with all this new space data, making it all line up so that you can do analysis in a temporal stack across different data types is really critical. And this is where having the people who ran the simulations for the Big Bang theory, the Big Bang, not the theory, the Big Bang itself, and understanding high performance compute and how you would do cloud computing really came together with a bunch of brilliant remote sense scientists to create a workflow for bringing in everyone's data, co-registering it, cleaning it, normalizing it so that it can then be used and show those patterns over time. So I think a company like Descartes brings in over 100 terabytes a day of different data sources, and then they sit there and they're able to look through the patterns, apply machine learning, and understand predictively what's going to happen with crops and other capabilities, other facilities and indications around the globe. And they're doing it on a global scale. They're not doing it on a small drone scale, though they can integrate drone data, but they are doing things like vegetation analysis in the first one. They're using the Sentinel synthetic aperture radar, so they can do the day-night all-weather and also take advantage of the phase information, so INSAR, and then understanding the soils. So they've literally found a way to look through something like 12 years of weekly data over a field, get a sense for whether an insurance claim adjuster should go out there when there's a hailstorm. So you can very quickly look through this remote sense data, and they can go back through their insurance claims, the insurance company, and see, how often has this farm given me a claim? And we can actually go back now through the Landsat data and actually say, was that claim real or not? Not me necessarily, but the different people at Descartes. So BlackSky, all right, I guess my slides got mixed up here. My fault. But again, this is that site monitoring with the assured tasking. So it's the accuracy. It's knowing you're going to get your data when you need it, and you're going to get the information, and hopefully at a time premium. Because as we all know, knowing an answer before everyone else makes that tradable data, and that gives you arbitrage, and arbitrage is decision advantage, and decision advantage has a revenue impact. Again, on Spire, so they have a whole constellation. We have a little bit more of an update on what their satellites, how many they have up in there, up in the constellation. And so they're doing both maritime domain awareness, just like Hawkeye. They're also doing their weather with the weather occultation. With their ATSB, they're starting to monitor air traffic. So you'd get a sense for if it's a premium product, say Apple's iPhone is about to release, then you'd start to see more of the planes moving back and forth. So you could potentially short the market or make different trades on the market based on the insights you have. So again, they're monitoring over 250 vessels, 250,000 vessels a day every 5 minutes. Those are over 30 million messages, including the terrestrial. So the amount of data coming through these systems, just like you prefaced, is just enormous. And so it can only be done with deep learning, machine learning, to understand what are the patterns, who are the people cleaning the data, et cetera. And these are some of their integrated data sets, which are quite beautiful. And this is actually their ATSB. So this is one of their newer shots, but it's showing you the planes in flight while they're heading over. So it's really impressive capabilities that are now coming to market. And with that, we are going to talk about the next generation of processing. But before we do that, I'll tell you the trends. So right now, space-based and ground data are only going to grow. But you already figured that out, or you wouldn't be here. Data, as previously said, it's the new oil. And today's satellite providers and analytic companies are poised for that growth. The killer app, it's not there yet. It's still got to be developed. People are really going to, we had the hash ups on the web side and on the app side. Those are still yet to be developed. I think we're getting there. Certainly, as the business models change and some of the data is either rented or the cost of data goes down or different rev share models come out, I think we will get there. If I looked at the EO models in general, the price to run your analytic, your ROI on that data is really hard to complete. So unless the data is free or lower in price, it's hard to get to that killer app because you don't have enough users and enough analytic providers playing with that data just because the cost of entry is so high. Clearly, I'd have to agree with the previous panels. AI, machine learning, deep learning, they're just required to deal with this veracity and velocity of data. And the satellite decision-based advantage, it is not considered insider trading. So that is, that's the money pot. Where is this all going to come? Why does it have revenue implications? Why are we launching all these satellites? It's because people believe they can make money and they'll have decision advantage over their competitors. And what am I? Sorry. We're strategic technology experts that enable startups and established industry to realize the full revenue streams and their technology roadmaps in order to get there. So it's which data do you fuse? Who are your leading edge customers that are willing to take a chance on you? How would you productize your different data sets? And who are some of the experts in deep learning and machine learning from either academia or the national labs or in industry that can come and help solve your problems?
Now we have Ohad.
So thank you for sticking around so late. We talked about transferring data. We talked about a little bit about analytics and fusion. We'll talk about that later on as well. But I want to start with, how do you store this amount of data? Even before why? So while it'll loop to my presentation, I'll say that I come on behalf of LyteLoop, and we at LyteLoop came with a brand new way of storing data. And you can see my slides back to front, so it's easy. And the idea is storing data in motion. Instead of having your data, and no matter what data it is, stored in hard disks, in a data center, and on SSDs, have it stored in motion, which means have it go back and forth in space between two satellites. And the storage is actually in the motion of the data. I use the word data so much, and we've talked about it so much in the last 30 minutes. I would just say it differently. Every single thing that we do, from social media to machine learning, AI, autonomous cars, Industry 4.0, social-generated content, you name the trend, you name what you're doing right now, it's data. We don't store it, we don't analyze it, we don't monetize it. We're not humans anymore. When we looked at the way that we're storing data today, which is just putting it in hard disks in a data center, we said there's a problem here. Well, actually 4 problems. First of all, the amount of data in the world is growing exponentially. In 2009, there was 1 exabyte, less than 1 exabyte of data in the world. Doesn't matter what a zettabyte is. There was less than 1 of those. Today we're at 40, next year we're at 60. In 5 years' time, we're at 160. We're just creating so much. We need to find a better way of growing exponentially with the way that we store it. It's using so much of our world's power, nearly 5% between computing and storing that data. We're running out of energy, power. We're killing our environment. And it's costing so much money. 2014, it cost nearly $16 billion in power bills in the US alone. Cybersecurity. I think it was mentioned earlier, but I would rather say it this way. The world is divided into two kinds of people. People who have been hacked and know about it, and people who have been hacked and don't know about it. We need to add more and more layers of security. Otherwise, if someone says, I don't care that my data is hacked, until you do. And last but not least, if you think about a data center for a second, and picture it for a second, it's just that. It's a physical center. It took a year or two to build. It's in a physical location which is sustainable to force majeure or to physical hacking. There is a certain regulation which you may or may not want to, or jurisdiction which you may or may not want to apply to it, but it still applies there. And it has to have physical infrastructure. Those are the four key issues that we at LyteLoop believe we can solve. We do have multiple applications, and each one will address 3 or 4 of those main issues. We're going to talk about the space, but just as an FYI, we do have 3 terrestrial-based applications, but the satellite and the tube replace a data center in its entirety, the storage part of it. The fiber and the cavity will replace storage within a data center, but the entire concept behind it is always the same. Having the data just go back and forth. The photons, laser communications will carry the data and will continue in continuous motion, creating endless loops until you need the data. I heard a lot about from the NASA's presentations earlier today, and they said that they're trying to travel at work at the speed of industry, and we're trying to work at the speed of light, which is a little bit hard because light is fast. And if you want to store a lot of data in a optics communication, on the highways, as we say, you've got to all have a very, very long highway or have a very, very wide highway. And we decided to do both. And I did say, or keep on saying we. So we are a team of 7 people so far, but the interesting people is actually the last 2 on the top of the list, and that is Professor Paul McManaman, Chief Scientist of the US Air Force Sensor Division, who's been our Chief Scientist for the last 3.5 years, and Professor Alan Wilner, who is in charge of multiplexing, of putting the highway, make it as wide as possible, while Paul is making it as long as possible without changing the speed of light or extending the actual physical distance that the light is traveling. So one kind of technical slide, and that is, how do we want to do this? And I'm using space as an example, but it's just an example. Let's assume that you have 2 satellites, geostationary birds, 6-ton birds, up there. Each one has an aperture array, which is a really nice fancy way of saying a mirror or a dish. And they're just communicating back and forth. How much data can you store? Well, you can store double the distance, because each photon will go from satellite A to B and back, times the bit rate, divided by speed of light. Since speed of light is constant, bit rate is constant, and distance is constant in all my examples, the capacity is based on the number of routes you can do. Since these birds or the satellites are very big, let's add more apertures. And if we add 4 times the apertures, we've saved a bit of cost on the bus size. But in general, we just added 4 times the resources. We've added 4 times storage. We've gone from 2 routes to 8 routes. Nothing major, nothing big here. Our second breakthrough after the entire concept of storage data in motion, that's our 3rd patent actually, is angle multiplexing. And angle multiplexing is a method that can be used again in multiple applications, including LiDAR, including other applications for data storage and others, is to make each one of the apertures communicate with all the apertures on the other side at the same time. What this enables you to do is it enables you to not to add any resources between the first example, the second example, and the third one. But the number of routes has gone up from 8 to 32 without doing anything. We've been able to quadruple the amount of data stored without doing anything. Now, the real cool thing, and sorry for saying cool about physics, is that if you add 1 more aperture to the example, and you have 5 apertures on each satellite, you've added 25% of the resources. But how much storage have you added? Well, now you have 5 apertures, and 5 squared is 25, times 2, that's 50. You just went from 32 routes to 50 routes, which is a 55% increase. by adding 25% resources. It's the first time that we're not increasing the storage capacity in a linear manner. We're going exponential, which is what we're doing in the real world. But then we said, but who needs big birds? Who needs 6-ton birds and geostationary? Well, this is a new space. So let's go with many small satellites. And that's way too complicated. Since nobody cares about formulas, let's actually talk about numbers. How much can you really store in space? A lot. Since most of us in the room are humans, your eye's gone to the bottom line. So let's look at the bottom line for a second. And in the bottom line, you have an example of 100 satellites. Each one is about 500 kilograms. Each one can see 20 of his colleagues. Each one has 2,000 kilometer distance between satellites. Relatively large aperture arrays, and each one has 500 watts of power for opticals, which is about 1 kilowatt of power. Completely reasonable. You can store potentially store 631 petabytes of data. Now, we've used here petabytes and terabytes and exabytes and zettabytes, and that doesn't mean anything. So let's talk about what is a petabyte. 1 petabyte is 500 billion pages of text. Nobody reads. So let's go on Facebook. Facebook is building the largest commercial data center for storage. It's being built in Singapore. It's a 1.8 million square foot building, 11-story building, costing a little over $1 billion, and it will store 1,000 petabytes. So this one line is approximately 65% of the world's biggest data center. So it's a real storage data center. Why stop at 500 kilograms? Why not go smaller? Maybe smaller is better. Well, it is. In this case, if you actually go smaller distances, smaller apertures, more routes, less power, you can actually store a lot more. And there are many, many, many examples we can give. But the bottom line is you can store meaningful amount of data in space, not necessarily to bring it down. You can analyze it while we're up there, and we'll talk about that in a second. But it's a lot more secure. It's in space, so it's harder to get to. It's moving at the speed of light, which is even harder. But it's moving, and it's optical, which means you can put in quantum encryption on it. And once I said quantum encryption, anything I said before is irrelevant, but there are 3 extra layers of security. And versus pretty much anything else that we do in space, this is the only thing that is actually cheaper to do in space. Because although it is more expensive to put it up there, once the constellation is up, there's no OPEX, or insignificant versus the amount of OPEX we have on Earth. So we are able to save on a total cost of ownership basis around 50% on a per terabyte, per petabyte basis. But it's not price and it's not security. We can do a lot of things if we keep the data up there. We can do, one, a non-infrastructure data center. A lot of countries, which we're connected with OneWeb, with SpaceX, won't be able to build data centers. Small islands in the Caribbean, middle of Africa. If you now have an application for 2-3 months, it'll take you 2 years to build a data center. If you don't have one, you can access it from anywhere. If you're a government and you're sending forces somewhere which you don't want to have the data with them, you can pull the data when it's needed. And if all this data is being collected in space anyway, or a lot of the data is being collected in space, why does it have to be brought down to be stored here, to be analyzed, and to be monetized? We could do it while we're up there. And I lied. When I said it's cheaper, I'm comparing 1 exabyte on the ground to 2 exabytes in space. Everything is doubled up. Everything is redundant. Everything is self-healing. That means that if you lose a packet in one constellation, you get it from a second constellation, or from a second loop. That loop could be a hard disk, a real loop, space loop, a tape. And that part actually is already working on our proof of concept, which has been working and storing data in motion on the ground on Fibre for the last year and a half. We've been able to store gigabytes of data going around for 300 billion kilometers. Let's put things in perspective. Voyager 1 has been traveling since 1977, the fastest vehicle we've ever done, 38,000 kilometers an hour. That has traveled only 24 billion kilometers. We've been able to send files out for over 300 billion kilometers and retrieve them error-free. And more importantly, the thing that we've been working harder than anything is actually the portfolio of patents that we've accomplished. And that is, they can be used both for telecom, for storage, and for many, many other applications. I think I've exceeded my 15 minutes, so I'm going to end there. Thank you.
Nicely done.
Thank you, Chris, Melanie, and Ohad. Chris, I wanted to start by asking you a question. You had mentioned infrastructure and the necessity to build out infrastructure, and you first brought up the fact that big data is oil, the new oil,
Yep.
right? So in building out this infrastructure, do you at all, and I'll extend this question to the rest of the panel in a minute, but do you see a need at all to democratize big data? Do you see a need to assist those that don't have the resources to access the data or the information gleaned from the data at all?
I think that that's one of the key motivations for me in starting the company that I did, is that I think that that as humanity, the planet stands to benefit from application of space data. And so I think it's critical to do everything in my power to make it easier and more affordable for everybody to enjoy the benefits of the value that is created through access to space and space data. So yes, I think that's absolutely critical. And but I understand that that has to be done in a sustainable way. And I'm not talking about environmentally sustainable, but that is important as well. But it needs to be done in a commercially sustainable way. I can have all of the ambition in the world to save it, but if I don't have resources, I can't do anything about that. And so that's the reality side that tempers the ambition to save the world, is that we need to be able to do it profitably and to be able to keep the company going. And so it's an important piece of that infrastructure and democratization vision.
Gotcha. And do you have clients coming to you with specific needs or goals, or do you get the information and then what's the process with your company? How do you go about working with customers and clients?
Yeah, so I think we take a different approach than a lot of other companies would, because we work with our customers to understand how they're going to make money. Sometimes customers will come and they will prescribe a solution, and often we can go back and say, well, are there actually ways that we can help you serve your customers' needs better? What can we do for you that actually gets you paid more so that you're more successful? What are your customers actually valuing? And as we're able to do that, certain things may become deprioritized that they thought were very important, and other things may become more important that they hadn't considered. And so I think having that holistic view that is really intensely focused on where we can create value is important, and that's one of the key areas that how we help our customers.
Great, thank you so much. And Melanie?
Yes, so there have been a couple of really fabulous things. The European Space Agency has made all of the Sentinel data free and available. Amazon has posted the Landsat data in its cloud so that it's already accessible for different people to use. So those are great data sets that exist there. I think Cosmic Works also has a resource of digital globe data with ground truth. And then you have, in times of disaster, I believe every single one of the satellite constellations I've mentioned provide their data for free to people in disaster management response. One of the other things that's going to evolve is the data, once you first collect it, is its most valuable, and over time it's less valuable. So in the future, I also see even the private companies, to entice people to come and work with their data, may provide the older data and its archive for free.
Okay, thank you. Ohad?
The first project I worked on the commercial side was in 2005. It was a fiber optics cable called the Easy, which was supposed to connect, or is actually connecting East Africa to the world. And the idea that behind that cable, which was actually financed by the World Bank at the end, was that if you have access to connectivity, the businesses around it will flourish. And the idea was customer service centers in Kenya and Uganda, and it worked. So I think that we have to give the access to connectivity, to storage, to computing, to analytics, to companies, to the local countries. And if they get it, they will be able to utilize it and actually raise up the education of the local population, the income, the GDP, and it's the only way to do it. We've got to understand as companies, as commercial companies, that the better we make the GDP of the world or the GDP of the emerging countries, the more that our pie grows. And yes, we have to give the access to infrastructure to these economies.
Mm-hmm. Great, thank you. I'll ask this question of you, Ohad. Do you see any conflict with your moving storage in space? Do you see any conflict that could arise between US law and international law? And are you at all concerned about that?
So I'm looking at that as actually one of the biggest values that we can. And again, for legal reasons only. Today there are certain reasons where you want to build your data center or you want to hold your data. If you're a European citizen, you want to keep it in the US, that may be a problem. But since I picked on Facebook earlier, I'll pick on them again. Facebook wanted to build a data center, or is building a data center in Canada. And according to Canadian law, if there's a data center in the country, you can get a warrant and get a hold of the data in the data center. But Facebook said, only for Canadian citizens. If you want a warrant, you can get it for Canadian citizens. The Canadian government said, that's not the law. And they said, well, if you want our money, change the law. Well, they did. We're not all Facebook. And therefore, I think that at the end of the day, we want ownership, legal ownership of our own data. And the way that we are looking at it in space is that most likely, and there's quite a few people looking at this at the moment, that if the data is actually stored between vehicles, and the vehicles do have flags, certain flags, but the data is not on them, then most likely the jurisdiction will be the data owner's jurisdiction, which is what we all want as humanity, to be the owners of the data, or the jurisdiction that applies to me as an individual will also apply to my data. So I think that's the next stage of data ownership.
Nice. And to the entire panel, how do you see big data affecting the workplace in the coming years? How do you see it affecting the worker, in various economies, and not just particular groups of people or entities? Go ahead.
As an engineer, I love efficiency, and I see the predictive power of data making almost every job more efficient. I like to joke or have a conversation with friends about if you showed me just about any business in the world, I could probably find a way that it could be made better through the application of space data and predictive analytics. And so I don't think there's a job on the planet that that couldn't benefit from this, and I think that the impacts are going to be accelerating.
Probably echo a lot of what Chris said and just add some additional information onto it. So if you take something like GPS satellites, so originally they were just for military purposes, and they still worked even though Europe's went out. But when you took GPS satellites and then you made them available to the public, we had this whole growth of location-based services. So now people can take the most effective route home, maybe the least amount of traffic, the least time spent, just idling your car. You can now walk into a store, and based on your user preferences from other algorithms, they can say, oh, you're in this store, this is what you want to buy. So to take Chris's point, the efficiencies enabled by the new space economy are going to be significant to GDP. So from Spire's perspective, their goal is to increase GDP by 2% globally. Right? But if you add all of these constellations and the impact they can have to global supply chain and better planning and the predictive capabilities, the potential is much larger than that.
Since my answer for analytics means stolen, then I'll go back to what I always tell my kids, and that's sharing is caring. And today with Teams, with applications like Monday.com, with Airtable, with Slacks, the ability to share data within a team, to freely share data, not using emails, but to have data accessible to everyone, and have people look at it from different angles and provide different solutions, I think that I look at my teams and that increases productivity incredibly. By having a programmer look at a optics problem, it's not supposed to be him, but he has the access, so he looks at it and he finds a solution. there are so many ways to improve things just by better communications and better sharing of information.
Great, thank you. All right, if we have any questions in the audience, we have a few minutes to take some questions.
Fantastic talk. I'm an analytics person myself, and this was like, I was like nerding out the entire time. So thank you for allowing me to nerd out along with the other analytics people here too. I have a question. In a fictitious universe that is probably an alternate parallel universe sometime in the future, where there is, where we have a base on Mars, where we have a base on the moon, and where there's people living and working in Leo, or elsewhere, but let's just say Leo for the time being, and the purpose of this parallel universe thing. Do you see the satellite thing that's happening now on Earth scaled to Mars, or scaled to, to help out, the tourism and help out people living and working in Leo? I'm looking more so at Mars just because I've worked with Themis data, and I was just curious, do you foresee, more high spectral, more high resolution sort of remote sensing imagery happening on Mars or elsewhere?
I'll take a stab at it.
I'm happy, I'll take it after you.
There you go.
You can take my answer.
No, you know what? Start with analytics.
Oh, okay. So satellites looking down on the Earth today, they do that because we care about what's going on the Earth. The ROI for Mars has been the realm of astronomers and astrophysicists, and certainly, since people have been young children, the sparkle in the sky has created enough to make us all want to go to space and watch all these rocket launches. So you could say we know more about space than we do about what's going on in the ocean, so space must just fascinate us as human beings. It matters not in Leo whether it's pointing down or it's pointing up, in Meo and Heo. So you can definitely expect that satellites will change their orientation as exploration and the space economy continues to grow. More importantly, they won't have to deal with the impact of our atmosphere like the astronomers have to. And that is why NASA in the 70s started launching telescopes out into space so that we could get away from the Earth's atmosphere and start understanding what is out there, both from a gravitational wave perspective as well as from a chemical element perspective. So at a minimum, communications are going to be required. So that's going to require satellites in our orbits and then perhaps satellites not in these beautiful atmospheric held orbits as well. But certainly as we do more space-based exploration, and the moon is going to become more important with the growth of the Chinese going to the dark side of the moon, not a Transformer movie, not Fringe, all happening today, right? So your parallel universe is happening, and perhaps it won't be because we're off on a frequency.
And I agree. Communications, there are certain applications which can only be done by satellite. So communications, if you do have colonies or settlements on other places, you will have to have communications. Satellite may be the best means of communications inter-colony or with Earth. If you want to do, for example, data storage, if you want to do a lot of other applications, you will have to have satellites around these planets.
Nothing to add.
I'm going to direct this question first at Ohad. So satellite pointing, and pointing accuracy, is that a limitation for the scalability of the solution? And perhaps more generally for the panel, are there hardware limitations that limit scalability?
So for us, it was a limitation. We've taken that into account, both the guidance concept, the size of the apertures, for example, that I mentioned above, take already into account that you they're a lot bigger than what you actually need. But that is one of the minor issues, and it's completely solvable. And it's been out there. I mean, communications in space, communication between AlphaSat and the moon has been done. Inter-satellite communication links are done. It's not one of the very minor issues that's already been solved.
From an analytics perspective, and certainly it's for these two gentlemen more than for mine, what matters to me is getting the data as fast as possible. So pointing and timing is really critical. Synchronized timing, so that both downlinks and if you're doing optical, right, you have a very short period of time, but they need to transfer high data rates. So timing becomes the biggest issue to me before pointing. But Chris?
I would say that generally my perception is that the technology is far in advance of demand. We're only limited by the value that can be created by the data. And there's kind of a push and pull there a little bit, but I think we see what the next few steps are to get faster communication and more reliable communication. And we're kind of waiting for some promise to come out of the applications and the value creation to justify some of those next steps. And I think that's one of the roles of government, is to be able to kind of push that frontier a little bit. And we're seeing that. We're seeing high net worth individuals pushing that frontier where there may not be a business case today. So I don't think it's a technical challenge as much as a commercial one that's holding things back right now.
Okay, that is our time. If you have questions, if anyone has questions, can they reach out to you after the panel?
Absolutely.
Okay. Thank you so much, everyone, for coming tonight.
Staying.
And staying. Yes.